In this presentation, I will introduce you to the most important merits of Ludvig August Kolding, whose lifetime spanned the central part of the 19th century. The starting point will be the year 1843, where a young polytechnic candidate presented a treatise to the Royal Danish Society of Science, entitled Some Propositions Concerning Forces. In the thesis he stated, where a force sensibly disappears, it only undergoes a change in form and remains thereafter active under other forms. The treatise was based on a deep religious faith. He stated the same forces that God from the first beginning created will continuously be active without ever disappearing or ceasing to exist, but also on physical experiments, where by dragging a sled variably loaded by cannonballs along rails of different metals and comparing the applied force to the heat expansion of the rails, he estimated the mechanical equivalent of heat. The printing of the treatise, however, was delayed several years. What he stated was actually, although in a vague form, the first law of thermodynamics, the conservation of energy. But was Kolding really the first one to do so? In 1842, Robert Mayer published a paper, Remarks on the Forces of Nature. And in 1843, James Joule published a paper on the calorific effect of magnetoelectricity and on the mechanical value of heat. In 1847, Hermann von Helmholtz published the book on the conservation of force, where he referred to Joule and also gave a more final version of the conservation of energy law. Later on, however, he recognized the pioneering works of both Mayer and Kolding. All the three of them, Kolding, Mayer and Joule, firmly claimed the priority, but it is now generally accepted that Mayer indeed was the first. This slide gives an overview of the career of the engineer, physicist and teacher August Kolding. The first given name he rarely used. He grew up as a country boy in Brøndby Øster, and instead of taking over the farm, he became a cabinet maker in Copenhagen by intervention of the famous Hans Christian Ørsted, who was acquainted with his father. Ørsted also helped him to qualify with the Polytechnic School, and in 1841 he graduated as a mechanical engineer. Then it was difficult to get a permanent position, which first succeeded in 1845, where he became inspector of roads and bridges in Copenhagen. 2 years later, he changed to become the water inspector in Copenhagen. In 1841, he was given responsibility for 3 major projects, citywide projects on water, gas and sewage in Copenhagen. And in 1847, he became chief engineer in Copenhagen, actually the first one. Here we should also mention that during almost 20 years, he was lecturing at the Polytechnic School. Every second year, from 1865 to 1883, Kolding presented a series of lectures on the fundamentals of drainage and of harmful water, supply of water and gas, and heating and ventilation. Thus, the Department of Environmental Engineering can claim that this year can celebrate the 150th anniversary for environmental engineering at DTU. To the left, you can see the first lecture written in the lecturing protocol from 1865, the 1st February. To the right, the front page of Kolding's lecture notes, handwritten and a total size of 320 pages. Kolding presented a remarkably broad range of scientific papers and treatises within physics and applied sciences. He published on thermodynamics, magnetism, steam power, hydraulics, soil physics, hydrology, heating and ventilation, and meteorology. and together with Julius Thomsen, the famous chemist, he also published on epidemiology. Much of his work was related to the work as city engineer in Copenhagen. And to the right of the slide, you can see the city of Copenhagen in the mid of the 19th century. The fortification was still intact, and inside this the city was extremely crowded and you can say overpopulated. Although, as you also can see, some expansion outside the ramparts had begun. The situation in Copenhagen when Kolding was implied was far from optimal. Water supply was based on surface water from Emdrup Lake. It came in wooden pipes, and it was insufficient in both quantity and quality. The hygiene was highly problematic. There was no piped drain system. There was insufficient removal of latrine and solid waste, and a terrible smell in the whole city. Proposals existed for improved surface water supply and a pipe sewer system by inspiration from the city of Hamburg. There was some sorts of gas-based lighting. This all ended up by arranging international competitions within water supply, sewerage, and gas lighting in 1849. However, before the water supply and sanitation projects were commenced, a tragic incident hit Copenhagen. A cholera epidemic reached the city in 1853, and by the end of the year, almost 6,000 people were dead. Kolding and Thomsen, in their remarkable and comprehensive work on the causes for the epidemic, showed that cholera was related to polluted drinking water and lack of sewage disposal. This was actually 1 year before the famous work of John Snow on the spread of cholera in London. In 1854, the water supply and gas lighting projects were approved, but the sewer project ran into problems. As mentioned, Kolding became responsible for both water supply, gas lighting and sewerage. And let us take them one by one. First, the water supply. He started out with a travel to England in 1850 for studying project over there. In 1851, he won the international competition on a new water supply system. And this was a real innovative project. It was based on groundwater supply from artesian wells around Damhus Lake and the raw water reservoir in Søndermarken. A waterworks should be built on the western glacis, which became possible due to the fortification was abandoned in 1856. The project start was in 1856 also, and it included 900 workers and more than 100 kilometers pipes were laid down. The project was completed in 1859. The gas lighting also required a travel to England in 1855, and the project on the gas net and the gas works was started in 1856. It included a tunnel to Christianshavn in the raw chalk, a risky project, but ended up successful. The gas project completed in 1856, and the gas lights were ignited. While the water supply and gas lighting projects went on smoothly, this was not the case for the sewerage. The preferred project in 1851 was based on separation of rainwater and wastewater, and this was actually 100 years ahead of time. But there was some disagreement about the necessary slope and pipe dimensions. The heavy opposition raised with reference to improved night soil disposal, but in the end the project was approved in 1853 by the City Council. However, despite the tragic cholera epidemic the same year, the project was turned down by the government after pressure from house owners. Then in 1854, a compromise was agreed on a reduced project that was based on combined sewer system without connection of closets. Again, a travel to London was needed for approval of the project, and also levelling of the whole city was needed, and this was carried out in 1855. The project was finally decided in 1857 and initiated 1860. Despite the extreme heavy load on Kolding on these three projects in the 1860s, he continued and pursued his scientific interests. And here I present some of his later scientific achievements. Independent of Darcy, but slightly later, Kolding found the law for movement of water in soils. He developed methods for determination of wind speed and ocean currents and introduced synoptic weather maps. He explained in detail the progress of the tropical cyclone that hit St. Thomas in 1871. And he determined the laws for wind-induced flow and set up in open waters, and explained the causes for the flooding of Lolland, the severe flooding of Lolland and Falster in 1872. There was a great demand for Kolding's expertise, and here are some examples. He acted as consultant on water supply in several cities and also did a lot of other tasks. From 1856, he became a very active member and auditor for the Royal Danish Society of Science. He was member of several commissions, and we could emphasize here the Commission for Adoption of the Metric System and the Commission for Implementation of the Daily Meteorological Service. In 1872, he was actually offered to become the first director of the Meteorological Institute, but he declined due to age. During his lifetime, Kolding received quite a few honors, starting out in 1849 with a silver medal from the Royal Danish Society of Science. In 1856, he was elected to the Royal Danish Society of Science, and in 1867 he became Knight of Dannebrog. Here we should perhaps in particular emphasize that in 1869 he became a professor at the Polytechnic School. In 1871 he became honorary doctor at the University of Edinburgh, actually together with Joule, who he met for the first time. In 1875 he was also elected as a member of the Royal Swedish Academy of Science, and in 1886, at the occasion of his retirement, he was promoted within the Order of Dannebrog. 2 years after retirement, Kolding suddenly died. Now we can close the circle. On his tombstone, raised by his 4 sons, the year 1843 is highlighted. And the stone bears the inscription, Naturkræfterne ærer uforgængelige, or the forces are imperishable. Thank you for your attention.